left you at predicting solubility. You can predict if a compound is soluble or not. Well, now what we're going to start to do is we're going to start to look at reactions and predict whether or not a precipitate will occur, whether or not we'll see a precipitate. So two ionic compounds, both in aqueous solution, are mixed. We've got a bunch of ions just swimming in soup. If there is the potential to form an insoluble compound, that's when you get a precipitate. So what were the compounds we had there? We had sodium carbonate and what was the other one?
Calcium nitrate.
Copper nitrate.
Calcium.
No.
Oh, sorry.
Copper 2 nitrate. Well, we got a precipitate, we know that. What was it? If a double replacement reaction here occurred here, can you predict the products of a double replacement reaction between these two things? Of course you can. So what are they? Give me the first one. Sodium nitrate. Sodium nitrate. Good old saltpeter. And we know there will be two of them. What's the other one? Copper carbonate. Copper 2 carbonate. Okay. Now, looking at a solubility table, such as the one you just had on your quiz. Which one of those is insoluble? Because one of them has to be insoluble, or we wouldn't have gotten a precipitate. We have one vote for copper carbonate. Anyone agree? Okay. Based on which rule? 5. Most carbonates are insoluble, and this is not an exception to that. Now, the sodium carbonate is. That's why we had a sodium carbonate solution. It's soluble in water because sodium tends to form soluble compounds. But this one is insoluble, so that was our solid. That was our precipitate. Okay. So we're able to predict which thing is going to form a precipitate. If we get a precipitate, we're able to identify what it is. This leads us to the point of starting to do net ionic equations. Okay. And you know what? I hate the way the notes are written for this. So let's actually just use the example of the two compounds we had. I'm going to take this, copy it, and we're going to walk through all the steps. Okay, so let's just take these two compounds, sodium carbonate and copper 2 nitrate. If you're told, hey, we're going to put together an aqueous solution of these two things, what you can do is write what's called a net ionic equation. It shows the reaction by showing which ions participate. So if we want to write what's called a net ionic equation for this, we're told we have these two things in aqueous solution. The very first thing we have to do is look at what are these things actually when they're in solution. We have to write a dissociation equation. So remember I said that was the first thing you had to know to do the next thing? Well, you know how to do that now. So we're going to write a dissociation equation for each of these compounds. So we take Na2CO3 as a solid. I don't have my good stylus, so my writing is really bad. And we write, this is step 1, dissociation equations for both things. So we get out of that 2 sodium 1+ ions in aqueous solution plus carbonate ions in aqueous solution. And we have to do the same for the copper 2 nitrate. So we have Cu NO3 2 times as a solid, which dissociates into copper 2 plus, and we have to remember that this is copper 2, so you have to be aware of those charges, in aqueous solution plus 2 moles of nitrate ions. Also in aqueous solution. Okay, so now we know what we're dealing with. When we have a solution of sodium nitrate, we're really dealing with a soup, or I'm sorry, sodium carbonate. We're dealing with a soup of 2 moles of sodium ions and 1 mole of carbonate ions. Okay, easy enough. Our second step, and we already did this when we were just discussing, is to write this as though a double replacement reaction would occur and predict the products. So you guys already did this. We can actually just copy it from back here. I'm only going to copy part of it. And what we're going to do on this is write in the state information that we have. So we have aqueous on our reactants. Let me shrink this. And what we traditionally do is stick a little question mark there. Now, of course, we already looked these up. But if we're dealing with new substances, we just say, well, we don't know what the state information is. So we go look up whether or not these are soluble. The sodium nitrate we said is soluble. So we're going to replace that by saying aqueous. The calcium carbonate we said is insoluble. So we're going to specify that that comes out as a solid. It precipitates. I'm going to move this up so that we can do that. Okay, now our third step, and this is the one that takes up the most space. Our third step is to rewrite the whole equation with the knowledge that these are actually ions that are going into it as the potential reactants. So we're going to, and I have the advantage here of being able to just cut and paste. So we're going to copy all those ions that we had and put those in our reactant side. Okay. So that is now our list of reactants. Because in fact, when we mix these two solutions, that's what we have, is a soup of ions. That's really hard to read. I apologize. Let me try to make it at least a little bit bigger. How's that? See if I can just sort of move these over. Okay, for our products, for anything that's still left in aqueous solution, guess what form those products are in? There's still ions floating around. So our sodium, we still have 2 moles of sodium 1 plus in aqueous solution. And we still have 2 moles of nitrate ions in aqueous solution. But the calcium, was it calcium or was it copper? It was copper. I'm sorry, I've been saying calcium. The copper and the carbonate are no longer in aqueous solution. Those things are now, and I'm going to have to shrink this just to get any room to, well, maybe I'll see what I can do. These things have actually formed a compound. They are no longer just floating ions. So we write that as a compound, and we put in the designation solid. That's our third step. The fourth step introduces a new concept. So, how many of you have ever been a spectator at a sporting event? Good. What does a spectator do? Yep. They don't break a sweat. They're not on the field. They don't score any points. They're not really doing anything. They're standing around and watching. I mean, maybe you're cheering really hard, but, you know, you're not doing a lot. Okay, Are there ions in this equation that are standing around doing nothing, that are not participating in a chemical reaction, that are ions when they start and they're still aqueous ions when they finish? We call them spectator ions. They're just standing around watching. They're not actually participating in a chemical reaction. So, name me one of the ions that's spectating. Sodium. We cross out our spectator ions on both sides. Name me the other spectator ion. What is it? The nitrate. Yep. We cross out the nitrate on both sides. So what we're left with, and we're going to recopy the whole darn thing. I'm going to shrink this part. What we're left with as our final step after we've crossed out our spectators is what's called the Net Ionic Equation, and that shows only the things that actually participated and it looks like this. That is a Net Ionic Equation. Okay, not all that hard. Now let me ask you this. What if we got to this step, step 2, where we were predicting solubilities, and every product was soluble?
Oh, God.
It's actually not that bad. What happens? Nothing. They all stand around and spectate. They all just hang out and wiggle their thumbs. And we just write, no reaction. It's not that bad. If they're all soluble, no reaction occurs. A reaction only actually occurs if 2 of those ions can join and form a product. If they're all still dissolved, and these are all ionic compounds we're starting with, which is all we're going to do in this chapter, nothing happens. We have 0 reaction. Okay, the additional practice problems, numbers 16 through 18 in the chapter 14 review. We'll grade all the homework on Friday. Let's just double check to make sure, but I think I remember correctly. Yeah. These notes are basically what we just did. So, writing net ionic equations. And there's an example of one for that. So, okay, that's where we'll stop. Tomorrow is Friday?
Yeah.
Good heavens. Tomorrow we will have a FIP quiz on writing net ionic equations. We will grade your homework, and you can get started on the end of the, I'll start getting the end of the year stuff up right now. So, start getting the links up.
Just 16 through 18, there's no practice problem.
Pardon?
There's no, like, practice problems, just the review. There's
No, they're on page 426, number 1, A through C, go with the review, but they're homework.
for this kind, I mean.
For this kind, yeah. They're probably, actually, there probably are practice in the book if you want to do them.